Hello everybody's. Alright, we're gonna have some fun today. So what we got here is a BBI 24 pill. We're not gonna say where it came from or who it used to belong to or who it does belong to actually. But what we are gonna talk about is this ability to dump heat. So we've got these four 3/4 of an inch 2200 Ripon Evercool ball bearing oilless fans in here, and he's saying the thing's getting a little bit too warm. So what we're going to do is we're going to do a before, we're going to do an after. So I've just got my little 2-pill hooked up, and we got a 100-watt slug going into the amp to show input power, and then we're going to come over here and we're going to put this on 1X. Now we're running the amp on 14 volts, so when we key this thing, we're going to put 40 watts in it. Okay. 40 out's going to get us a 500 watt dead key. 500 watt, 500 watt. Okay, so now what we're going to do is we're going to sit here with this thing dead keyed. Let's see, can I get a better camera angle here? Give me just a second. I got to get this set up better. Give me just a second. Okay, I think I got everything set up. One last thing is to tape the mic down because I don't want to have thumb cramp from this. It's going to be an interesting test. We're just going to key this for a couple minutes, and we're going to unkey it, and we're going to modify this thing. So let's go ahead and get this party started. I'm going to turn that on. Mic too close to shit. Alright, so we're keying our 500 watts. And now what we're looking at is you're going to see right through here is the grill, the fins for the back side of the amplifier. Let's go ahead and turn this on and start. We're going to let this go for a couple minutes. We're just going to throw a 500 watt carrier. We're putting 35-40 watts in it. We're on 14 volts. We want to see how long it takes this thing to get warm to where the exhaust air is hot, right? So we're seeing 65-degree exhaust air. It's a 30-second key. And we're nowhere coming near being able to hurt this thing. So now you can see the temperature starting to come up. So now we're at 70 degrees. And the customer's biggest concern was the heat being generated by this thing. He says when he goes to talk skip, the thing is getting a little warm for him. I said, okay, we'll send it on up here. We got the solution. So 500 watt carrier, dead keying for 1 minute and 15 seconds. We're at 75 degrees. Now we're going to start to climb in heat really fast because the heat sinks have reached their saturation point. Oh yeah. Now, and we're climbing quick if you notice. Two minutes. We're going to cut it off at 90, all right, which we're coming up on quick. No, we'll make it an even 100 degrees. How about that? No, 90. I don't know. I don't know. off at 100. And 100. I'm off the key. So stop. So roughly 3 minutes and 30 seconds at 100 degrees. And we're still climbing because heat's still getting transferred from the transistors. See, we're off the key. We're unkeyed. And let's see where it crests at. We're at 103 degrees, so we're done transmitting. 104, so we're still climbing. Just goes to show you it's not done. Thing isn't cooling off until you. Oh, I've seen 106. Are we going in reverse finally? Nope, we're still going. It's not actually done cooling off just because you're done talking. So 3 minutes and 30 seconds is what I gotta beat. Kind of stretch that out a little bit more. And then we gotta increase its ability to cool itself. It's still climbing, huh? No, no. Oh, are we going in reverse yet? Now we're going down. Are we? No, it's 106 degrees still. It's just hanging loose. Okay, we're starting to go down now. Turn that off. So now what we're going to do is I'm going to pull these fans out. I'm going to replace them with these. That's 4 120 millimeter, 130 CFM apiece blower fans, basically. Okay. So we're going to see if we triple, quadruple, put almost... let me think about this for a second. 6 to 7 times more air through the cabinet. How much longer we can drag this out for. Okay, so give me just a minute, we'll be right back. Okay then. Okay, so same setup as before. Stopwatch, heat, or the FLIR's in the same place. We're up a degree or two, but that doesn't matter. So, let's turn this on real quick. So 400, dial this up. So 5 more watts drive, everything's the same. Okay, let's get this camera set back up here. All right, so let's do this to it. 3 minutes and 30 seconds to 100 degrees. Let's see if we can make this stretch out a little bit more. Turn the amp on, turn that on. And here we go, we're keyed up. Let's start. removing some air now. It's at 86 degrees. Really interested to see how much longer this is able to keep. So we're right on track with where we were at the last key test. Degrees. Couple more seconds of key down time out of it. We'll see how quickly it cools off. Remember, it crested at 106 degrees last time. Now we're moving 4 to 5 times the volume of air through the cabinet as we were last time. Oh wow, look at it cool off. I'll be dipped in pig poop. Remember, it crested at 107, 106.9 last time. I'll be damned. Interesting. Dropping off in temp. Look at that. So the reason I find this so interesting, we're just going to continue to drop. Let me talk here for a second. Thank you, fans. The reason I find this so interesting is because you reach an apogee point, right? With the amount of air that you can stuff around the heat sink and underneath everything and by all the wires and everything underneath the bottom, you can put more pressure. and you can get more airflow. But does that mean that the heat sink is going to be able to rapidly dissipate the heat any better? Yes and no is what we just proved from this test. It's very interesting. Very, very interesting test. Well, guys, I'm going to go do some other stuff. I just thought I'd share this little test with you. I just learned a lot. Now I'm going to teach you all. And hopefully my students, the guys that follow along with me and let me teach them what I know and encourage them to go teach themselves and educate themselves, those little unit of guys can learn from my mistakes I've made today. All right, so the last portion of the video, we had fans inside the cabinet. Now we can obviously see they're outside the cabinet, and I got to explain to you how we ended up arriving there. So I did the key down test on the last set with the last set of fans. Oh,
yes, master.
Rise.
My teacher. Let me mute my phone so we're not interrupted anymore. That was my teacher checking in, telling me something. Okay, so I did the key down test with the fans inside the cabinet. So that was just driving it with a 2-pill, and that was at a static carrier, okay? Because what we were testing for was heat saturation inside the cabinet versus air velocity and its ability to transfer heat and conduct it out to the outside atmosphere. All right, well, remember how we talked about how the fans are thicker? These are the 4 fans that have been in this amp now for almost a year, okay? There's a huge difference in thickness. That amount of thickness makes a difference night and day on if the fan's circuitry is going to survive. Now, I thought I was going to be able to overcome that because the body of the fans that are on, that I originally started out with here, these are $15 or $18 a piece. So we'll just say $20 a piece fans after shipping, right? These are all metal body constructions. The body of the fan would help insulate the controller board. Well, the controller board actually sits up inside of the fan body, so the RF can fully encapsulate the board. It took me a little while to figure out what was going on. When I went to drive it up with the 4-pill, I was sitting there with the customer on the phone because we were doing some wattage comparisons compared to what he sees versus what I see on my bench. We found out our numbers are actually pretty close for the most part. Turn that slug around so I can show you what I'm putting into it for drive. In that process, I modulated it up and I drove it up to about 5,000 peak watts. And when I did that, when the fans were on the inside of the cabinet, this fan, and this fan stopped immediately and then started spinning in the opposite direction. This fan here completely stopped. Well, the whole output combiner ring and everything's over right here in this corner. I was like, oh wow, RF got in the fans and killed them. So when I unkeyed, these quit spinning in reverse, which they went from suck to blow, not to quote Spaceballs or anything. Holy crap, man, she's gone from suck to blow. Giggity. That fan never turned again, and these fans instantly quit. So what I did is killed the MOSFET switches that are on the inside of this thing that control the pulsating currents inside the fan housing that allows the fan to turn. Okay, because we oscillate the positive and negative poles, and that's what turns the fan and dictates its rotation direction and airflow. I killed that little controller IC with RF. And I had the fans wired exactly the same as these were wired. I went, wow, okay, I must have done something wrong. So I reach over on the shelf and I grab another $20, $40, $80 worth of fans and put them in the cabinet. All right. Well, the 4 fans that were in there have already gone on to Jesus. This whole process now has taken 4 days, and it's just because of the availability of fans. When I buy the higher dollar fans like this, because a lot of people don't want to have them because of the noise, I don't keep these in stock. I usually order them. We'll come back to that. So I ordered some more fans, and this was supposed to be a very quick process. Like, this thing was supposed to show up and the same day it was supposed to go back home. Okay? In theory, it would have worked if I would have known what I know now. It would have been in and out of here, wham, bam, thank you, ma'am, Tijuana sandwich, have a nice day. As soon as I keyed it the next time around with a new set of fans in there, it killed all 4 fans instantly. So I'm like, okay. And I only had 4 extras at that time. Now I've got several $100s worth of extras. I've got probably a whole case, which is like 24 fans or something, 32 fans or whatever. I said, shit. So I ordered some more fans, explained to the customer, man, I keep frying fans. And I ended up finding a guy here in town that sold me these fans, these plastic bodied fans. He actually had the metal bodied ones, this same style, not the same manufacturer, but they had a lower CFM rate. So these are about 140 CFM a piece. These plastic fans, supposedly, and I'm a real firm believer in this now after doing a 1-to-1 comparison. If you follow along on the Facebook channel, you would have been able to see that this morning. I did a 1-to-1 comparison from this fan to this fan. This one has probably another 600 RPM difference between it. That and it's got a higher blade count. Let's count the blades versus count the blades in the metal body fan. Okay. The inner body's smaller, so the fan blade volume is higher. This has, supposedly, according to the paperwork, 220 CFM worth of pressure to it. I don't think so. I think it's closer to 190 to maybe 200. This is 140 for sure. These fans shit and get with it, and that's the reason I bought these. So I tried them this morning. So first thing I did is I tried 2. Killed it. And what I was testing for was proximity. So if I have it so that the controller board, which is this side of the fan down, where the air is flowing into the cabinet and across the components and out across the heatsink, is what you want, by the way. And my argument for that is, if you change it to where the fans pull air out, you're preheating the air before you're asking it to cool the components. So before the air can get across the components and exhaust the cabinet, it's already reached its max saturation point. So therefore your resistors, the top of the transistors, the transformers, all the other components inside the cabinet aren't going to receive adequate cooling by pulling a vacuum upon a cabinet versus putting pressure upon it. Now we all know from the laws of thermodynamics and, well, laws of physics, it's easier to pressurize an enclosure than it is to pull a vacuum upon it. Meaning it's easier to put air pressure inside an enclosed space versus trying to pull down and reduce the air pressure or volume on the inside of the cabinet. If I flip the fans over so that the controller board is towards the top where it is pulling air through and out, okay, the fan survives, it can run. And that all has to do with the proximity of that board to the circuitry inside the cabinet versus the EMI effect that is taking place around the overall portion of the controller unit. So I didn't want to accept that. Me personally, fans on the outside of the cabinet are ugly as sin. Me personally, I think the box should be as smooth and slick and beautiful and without ruffle bumped edges on it as possible. Apparently, come to find out, that's not going to happen. Not because of the, because of the size of the cabinet. The Skullcracker fan, some of the Dominator cabinets, Skullcracker cabinets, Dominator cabinets, those kind of guys, their cabinets are a little bit taller. And literally a half an inch makes the world of difference in if these fans are going to live or not. Apparently when one fan takes the electromagnetic hit, it has a tendency to send a pulse back through their other and kills the rest of the fans. These pull an 1.5 amps a piece. These pull like, was it 0.75 of an amp, okay? I felt comfortable having 4 of these on a switch. When I went to the 4 of these, I ended up putting a relay in there. So now, Mr. P, your fans are controlled by a relay. Your on-off switch, all that does is turn voltage on and off to the relay. So there's 0 voltage restraint going to the fans at this point. So I eliminated, it's all a proximity issue. So I tried and tried and tried. I tried several different ways of mounting the fan inside the cabinet with different choking, torides, freaking caps, disc capacitors to throw the resonancy of the circuit off, lifting the ground. It didn't work. In this particular situation, it just didn't work. Now, I'm sure, and I know for a fact, that somebody out there is going to be like, here, look, BBI, I got it to work on mine. Hey, man, great. If you did, call me up and tell me what your trick was. I'm just done throwing $100 bills at it. And time. This is supposed to be an in and out thing. Not 5 trips to the fan guy across town and ordering stuff in second day air in the middle of Christmas. And it just needs to be done. And so my brother was like, do you think he really cares if the fans are on the outside or not? Or do you think he just wants to have functional? And I went, he probably just wants to have functional. So we went with putting the fans on the outside of the cabinet. Now, the other thing is my brother asked me, he goes, man, do you know what your wind velocity is? And I wish I would have shot an exhaust air velocity. It didn't even occur to me. Shoot a little portion of a video. Because I didn't know it, I have the ability to measure the actual volume exhaust air rate, and I'm going to share with you how to do that here in-house. And I didn't know I had it. My brother was the one that had to point it out to me. I wish I would have had a control, because I did a control the very first portion of this video that you watched, or with the heat test, and I could have showed you the velocity of the air leaving the cabinet with these 4 fans in there. Well, these are gone, so we'll keep those around for spares. I'm sure somebody's going to need them. These guys here just file this stuff in the appropriate place. It sounds like I'm just throwing $100 bills on the ground, doesn't it? Basically what I'm doing. My brother says, man, you've got this badass rangefinder. I'm like, yes, I do. What's your point? And he goes, well, my badass rangefinder I just bought for myself has this cutesy little wind gauge on it. It's a fairly accurate means of measuring wind velocity. Taking into account how much this stupid thing cost, I would have to lean towards it's fairly accurate. That and the data that I get from this allows me to throw bullets literally 2 miles or better. Okay. So when I did I'm not going to video that. You just take it, plug it into your phone, and literally hang it down here by the vent, and you can see the velocity of air coming out. We have 34.2 mile an hour worth of exhaust air coming out of each one of these vents. So I wish I had a control, then I could give you a gauge on what the difference was. So let's go ahead and reshoot our video now that we are in our final configuration here. Now guys, remember, I have a forward-looking microphone on this camera. So the microphone's literally pointed, and we're right next to the vents and right down next to the fan. I went with the metal body constructed fans, by the way, because they are tougher, they are stronger. This is going to go on a guy's truck, and I don't want the fans to break. That's why I didn't go with a plastic bodied fan. The plastic body fans, yes, have a slightly higher CFM by almost 50 CFM a piece, which would be the equivalent of having another 2 fans on this cabinet. But after doing my wind velocity measurements, I determined that if I go more than 4 fans, I am pissing in the wind. You can't get any more air to move through these vents. Actually, 3 fans doesn't provide you any more, anything more than 3 doesn't provide you any more velocity. Otherwise, exhaust, the ability for the cabinet to let the air out. I think maybe if I went in here and I cut these fins out and maybe tuck the wire a little bit closer to the board, I could squeak another 2 or 3 miles an hour out of it. This cabinet is moving as much air out of it as we possibly can. I mean, yes, I could probably go get 1,000 CFM Daikin blower that had 3-phase shift in it and all this other stuff, and I could probably put like 1,000 CFM fan on there and get that velocity to come up, but that's another whole level of extreme. So on that note, boys and girls, we have everything set up as we did before. We're going to throw a 500 watt carrier, and our base temperature is 65.8, and I think when we shot our very first video it was 65 point something. The time to beat is 3 minutes and 32 seconds. We're measuring key down time over air velocity, volume through cabinet, and heating issue to 100 degrees. So once we hit 100 on the FLIR, let's do something with the FLIR, that way it stays on. We're pointed right directly at our exhaust vent. We're the same distance away. Let's shoot this little test. Let's shoot this little chuck wagon and get it over with. All right, so there's our timer. Let's go ahead and reach up here and grab a radio, and we'll see you in 3 to 4 minutes. Radio is on. Here we go. Key up. Here's our 40 watts of drive and our half kW deck carrier. Okay. Let's see how long it takes us to get to 100 degrees. Is at 14.6, so 1/10 of a volt off, and I'm not going to dick with it too bad. I'm really ready to be done with this project. That needs to go out and mail today. Alright, so we are a minute in, and we're at 72 degrees. You guys, I like teaching myself this kind of thing, and you don't learn unless you're able to experiment. And a lot of the things I know I had to teach myself through experimentation, because don't forget, I'm all the way out here in Idaho. I don't have, you know, a Ghost Rider right down the street. Hell, my teacher Prime is what, 700 miles down the road. It's a 9-hour road trip to go see him. I mean, you can learn so much on the phone, but a lot of this stuff you have to have self-initiate, you know, a little bit of a initiative on your own to go learn it. Try it and experiment. And I don't mind throwing a couple $100 at a project to teach myself something or learn something new or discover something I've done wrong. It's called being human. I don't know, guys. You think we're going to make it? 2 minutes and 30 seconds in, we're at 86 degrees. The thing I did notice is by putting the fans on the outside of the cabinet, I picked up quite a few miles per hour of exhaust speed. And I think that has to do with acceleration distance of the airflow into the cabinet. Yada, yada, yada. Partridge in a pear tree. Oh yeah, we're going to smoke that 3-minute time. Look at that. 3 minutes. We're only at 90 degrees. So putting the fans on the outside of the cabinet for a competition box makes a huge difference. All right. Wow. Wow. Cool. Sweet. We're past the 3 minutes and 30 seconds. 3 minutes, 32 seconds. Did that just go down? Nope. I'm super stoked. Super stoked. Now let's see what happens. Because remember, in the first test, when we shut shut the amplifier off, it continued to climb. It went up to 106 or 107 degrees. If memory serves me right, that was 4 days ago and like 8 projects back. See how long it takes for it to reach its maximum saturation of heat and then to overcome and then start cooling itself off again. There it is. We're now officially cooling. That's amazing. We got a whole nother full minute out of it by putting the fans on the outside of the cabinet and going to higher velocity fans. Which if you think about it, that adds up in your key down time significantly. It's neat. It's an awesome result. Awesome. Cool. You just sit there and bake itself out for a minute as I wrap this puppy up. Guys, my name is BBI. Some lessons in life are learned the hard way. Some lessons in life you get to be able to find somebody that can teach you something that they learned the hard way. This was a lesson learned the hard way. Sometimes the fans on the outside, it might be uglier than sin, but there's a reason somebody before you went this way. I always used to tell myself, man, if I ever have to put them big ugly high velocity fans on something, I'm going to figure out a way to make them work inside the cabinet. On a small little enclosure like this, not possible, because of proximity. Now, if I had a 32 pill jumbo cabinet that I built this in, that would be a different story because the cabinet's taller and the distance from the board and the components to the controller board for the fan is smaller. Lesson learned. Money well spent, in my opinion. Gentlemen, my name is BBI, and without a shadow of a doubt, I'm the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, Instagram. And if this is your first time watching my video show, this little talk show I've got, the You Garbler porn channel for amplifiers, subscribe. Make sure to hit the notification button, or otherwise YouTube won't let you know I did anything. And if I didn't answer all your questions about this particular project or whatever your problem is in the future, don't hesitate to call that number. That's how you reach me. All right, guys. This thing's off to UPS like as of this minute. I'm gonna put the rest of the screws in it and it's out the door. I'll see you guys. I appreciate you all tuning in. Bump, bump, BBI gone. Woo, BBI failed on camera. Oh no, but he fixed the problem.